Hey guys, my name is Darshin Shah.
Hello, my name is Disha Suresh.
Hi, this is Neel Nishant.
Hi, I'm Palak Toshniwal.
Okay, let's get started. We have named our language as Profit, and the pro is derived from the word is derived from the language prologue, and the fit is to say that we want to believe that our language tries to fit all kinds of problem solving. And as an overview, we as a team will speak about the key features of our language, the design of the language Profit, grammar rules, sample runs, and then show you how to execute and run our language. Each member of our team has collaborated on all modules with a lot of enthusiasm and zeal. And talking about the key features, we've implemented primitive data types of int, bool, and string. Along with this, we've also allowed operations on int and bool. With this, we have support for logical operators, that is for and, or, and not. Support for arithmetic operations are also implemented in our language. And for now, we've limited that to addition, subtraction, multiplication, and division. Moving on to the next set of features. We also have support for assignment operator, and we have support for multiple conditional statements. That is, we have support for if else, while, for in range. And along with this, we also take care of ternary operator, and we have support for print statements. And we wanted to include a few extra features. So we've implemented the support for relational operators, which includes all the ones that you can see on the screen, which is equal to, not equal to, greater than, lesser than, and so on. We've implemented the support for parentheses in our expressions. We have default values for int, which is 0, for bool, which is false, and for string, it's an empty string. Along with this, we as a team believe that correct precedence and associativity is very important. So we've implemented that throughout our grammar. Next part will be the design of the language, and Darshan will be letting you know about that. Darshan, over to you.
Yeah, thanks, Disha. Okay, so the design of our Profit language is this. We have a Python file which is running over a PL program. Our PL file has our parser and our evaluator. The Python file takes care of the tokenizing the inputs and then giving it to the Prolog console. Okay, so this is our pretty much design. The source code is given as input to the lexical analyzer in Python, which generates tokens to give it to the parser in the Prolog, which in turns give it to the evaluator. This is a runtime engine which generates output using print statements and also gives us output in the form of environment and an intermediate code. All this thing is printed using a Python script that is running over our Prolog file. Some specifics about the design: that the source code has to be named as filename.pro, the extension. The lexical analyzer is our basically the profit.py file, which takes input as a file and gives output on screen. Our parser profit.pl has our DCG, definite clause grammar rules, and then the same file has our evaluator separated by comments, which gives syntax-based semantics to our output of the parser, which is a abstract syntax tree. Next, over to you, Disha, the tokenizer.
Thank you, Darshan. So when we have implemented our tokenizer in Python, and there is nothing out of the box here. What we're doing is we have, so like Darshan is displaying here. So we have a method called lexer, which takes the file name, and then the entire file is run character by character, and then it generates a list of meaningful tokens. Let me quickly show you how that is done. So in here, once we are inside the runtime file, on that note to mention, we have uploaded around 10 sample code runs for our language, and we've uploaded that in the data file in the data folder. And once, in order to run this, once we are inside the runtime folder, we run the profit.py, which is a Python file, and then you give the file name as, which is one of our .pro extension sample programs. And then once you run it, you get this entire token, which will next be sent to the parser in order to generate a parse tree. Neil will let you know more about that. So over to you, Neil.
Thanks, Disha. So the grammar of this language is written in Prolog. The program predicate here helps to evaluate the structure of the whole program and creates a parse tree. So the declaration, the D predicate is for creating a parse tree for the declarations. So in the declarations, we can have constant declarations, we can have variable declarations, and we can also assign the values in declaration itself. The C predicate is for creating a parse tree for commands. The command predicate can assign values to our data types like string, boolean, or integer. We have two types of iterative commands, while and for loops. We have two types of conditional commands, if else and ternary operator. We also have a for in range, which is similar to our standard for loop with an easy syntax. The B predicate is for creating a parse tree for the boolean. The boolean predicate checks for logical operations such as and, or not, and relational operations like the equal to, greater than equal to, less than equal to. The expression predicate is for creating a parse tree for arithmetic expressions. We have taken care of the precedence with the highest precedence given to the bracket and the lowest to addition and subtraction. This is a sample program. I'll show how it runs. So this is how a parse tree is created. Next, Palak will walk you through the evaluator. Over to you, Palak.
So now I'm gonna give a walkthrough how our evaluation works. In the evaluation, we are allowing user to give two arguments, system level argument, which is argc and argv. The user can provide while running the evaluation. After that, we are going to evaluate the block. The block further subdivides into a declaration and command. In while evaluating the declaration, which further subdivided into multiple declaration or constant declaration, boolean declaration, integer and integer declaration. For constant declaration, we have added one extra flag in our environment. If it is false, then the assigned value is constant and it cannot be manipulated. And if it is true, then the variable can be manipulated. Um then we have done the evaluation for the command. In command, we have assignment evaluation, string assignment. We have done evaluation for if else statements, while loop, for loop, and for and then in the expression, we have done evaluation for arithmetic expression such as addition, subtraction, division, and multiplication. Coming back to booleans, in booleans we are evaluating the logical operators, the relational operators, and the true and false. Apart from that, we are storing the variable or the state in an environment in forms of key and value pair, where we have defined lookup predicate. A lookup will basically check the value in the environment and return the value to the current state of the program. Uh, then for while manipulating or evaluating, if we have any update, if we need to do any update of the value, then we have the update predicate. Update will update the id and value into the environment. So that's all about our evaluation. Now Darshan will give you the demo for the installation. Over to you, Darshan. Darshan, you are on mute, I guess. Can you please unmute?
Yes, I'll go in and share my screen. I'll walk you through the steps you have to take to clone the repository first. So the first step is to clone the repository. We'll go ahead to a location where we want to clone our repository. And then, for example, this demo, we want to clone it here. We'll take the directory, we'll go to the command prompt, and then we'll change the directory to the directory we want. And then we'll give a command here. This is the command to clone our repository with our link. Okay, and this will create our repository in that folder. The next command is to install a library for Python. So we require that Python is installed on the machine. This PySwipe library is an interesting library which bridges the gap between Python and Prolog. It lets you fire queries in Prolog with use of Python scripts. So we will go ahead and install this library like this. This is a simple command, pip install command, and this will install PySwipe into your machine. The next step is to go into this folder inside the source code runtime folder. I'll show you what the folder looks like. So here we have our Prolog file and the Python file. The Python file runs over the Prolog file. We'll change the directory now to that folder. In the command line, we change that, and then we'll just run our profit.py file with this sample 11.pro, which is the path to our file. This is a relative path. You can give an absolute path, which does not uh, do anything wrong. And when you run that command, the first thing you'll see is your query, which the Python script generated, the output, which the parser and the evaluator gave it, then some console messages. If at all there are some errors, you'll see them here. If it is compiled successfully, you'll see this kind of message here. And then additional arguments like the intermediate code is also printed out, and the environment of all the values which you were using, you'll get to see the values here. To read this, it is like C has a value false and it is true, means it is changeable in the environment. And so the next thing here is our future work. So we aspire to implement object-oriented support for this language and include function declarations that also support complex data structures like arrays and lists and other things. Also some operators, new operators to the unary operator, so on and so forth. Thank you so much.
So our program has a small restriction where the last command should not have a semicolon. So I'll just share my screen and show it to you. So in the sample program, if you see, the last print statement doesn't have a semicolon. So that's how we have implemented it. This is one of the restrictions of our program language. Thanks.
So here are a list of sample videos. This is our first sample program. And in order to run this will be our query, our output, and our solution. I'm going to repeat the same for a few more. Second sample program. Our solution. I'm going to try the sixth one. Meanwhile, this is our file. We also have one fail scenario, which is says X is a constant value and cannot be modified, along with error messages. Thank you all for taking the time and for patiently listening to us. We hope you like Profit, and thanks from all four of us.
Thank
Have
you.
a good day.
Thank you.
Have a good day.